Right. Okay, yeah, explain. If you feel comfortable, tell me how the readings don't intimidate you or whatever. So, I mean, I would hope that you have some background from your programming course or courses here to make it achievable, but I mean, what are your thoughts on it? Is it, you know, is the stuff in the PowerPoint difficult at all, or?
Seems like stuff we've gone over in other classes.
Okay.
Yeah, it's familiar material enough. It's just still stuff I don't like looking at. So it just hurts my eyes.
If you got paid enough,
That might
maybe
change.
for $50 an hour, you could look hard. All right. So last time, last time I was talking about, well, reviewing a little bit about just some of the basic aspects of the language, and those are listed in each slide deck under the learning objectives. So in this one, even though this is a really complicated set of code, you get to learn in this slide deck about how to declare variables and how to set them, and the fact that variables are declared to have a certain type. Talked about this using statement, which means you're using an existing library of code, and using the name namespace means you get to create your own libraries of code. Let's go on to the next one, control statements. Regardless of which programming language you pick, there's got to be this idea of control. Particularly things to deal with if statements, like if this, then do that. Otherwise, do if else, for example, is a common set of terms for logic and making choices in programming languages. Another thing that happens related to control is looping. So in this screenshot, which puts together about 5 different things, I see an if statement in the upper left. I see a switch case over here, which is a different type of if statement. You could do the same thing with a really long if, else, if, else, if, else. For those of you who've seen programming before. If is probably much more common than switch. In the middle, in the lower left, in the lower right, we have examples of iterating over things. We have this do while loop. So in these parentheses, there are these conditions, less than, greater than. So oftentimes we have numbers. They get incremented every single time you go through a loop. And every time it passes through, regardless of which type of looping you're using, there's some mechanism for checking whether a condition still holds. The for loop is probably one of the most common ones, although it might be a little bit harder to learn at first. The idea of arrays. Before you saw how variables were declared in the very first slide. The difference with so you'd have something like an integer. If this were the first set of slides, there would be no angled brackets here. It would just say int my int equals new int, something like that. And then you could set it equal to some number. These angled brackets here allow you to use one variable to hold as many different types of that thing as you want. Which sounds, I don't know, does that sound strange at all? You want to know, like, when would you do that? Why would you do that? Now, let's see, when would we want a group of numbers? Sometimes we just have an arbitrary group of things. So we could have like a string array and call it colors, for example. That would be one. So rather than int, down here we have this one that says string, my string array. So if we have, if we decide, if we want to have a list of 5 strings, or sorry, 5 different colors, we could set this equal to 5. And then, so using one variable then, we could just have my string 0, my string 1, my string 2, my string 3. And this single variable name could hold 5 different colors. If we wanted to have a group of numbers, we could, again, same idea. A more advanced topic here would be collections, meaning that you use some variable to hold a whole list of things. So perhaps a variable that holds a whole bunch of numbers, like primes less than 100 or something like that. Maybe that doesn't have a lot of meaning or utility to you here, but in maybe a more practical way of using it is, imagine if you read a whole bunch of customer records out of a database. You might want something very similar to an array, a collection of customers. So you might have one variable that's called customers, and in it you would set a whole bunch of different customer objects in it, or customer records, and then you use those control structures we talked about before, the while loops. So you can do these little functions on them, saying like, you could say like what the size of something is. You could say customers.size, figure out how many elements there are in this one variable, and then do a loop to loop through it. And every single time you loop through it, maybe you want to print out the person's name. So it makes a lot of sense in programming to have things that group a whole bunch of things that are the same together, and then it'll give you a control structure to loop through them, so that you can maybe read one field out of each one of them.
This is like the type in C, like.
Is it like a type in C?
Yeah, like in C you can do it, I think basically the same. You just say, like you declare a variable and then you put like group of things, like maybe you want like a cell phone and address.
I think of a type in C as more like an object.
Okay.
Because you're grouping together a bunch of things into one variable that are related. So you might have, like a structure or a type related to a bank account. And so it might be, the checking account balance and the savings account balance, and you group those things together. I feel like that idea of having 2 different, maybe different variables that are part of one thing has kind of now morphed into objects, which not only have the data attributes, but also have behaviors. So methods that are associated with acting on that data. But that's the way I think of it anyway. Okay. All right, so anyway, you can, if you want to ask questions about arrays, just otherwise I'm just kind of breezing over this stuff. All right, objects. Okay. So I like to think of objects as complicated variables. Maybe we could compare it to an array, I guess. An array usually has a group of things that are all the same. An object is a container that has a whole bunch of different pieces of data in it. So we've been working with objects since the very beginning when we were doing our class diagrams. So when we talk about objects or classes abstractly, we draw our box like that, and we give it a name of some type, like customer, and then we say the stuff that's in it, like F name, L name, etc. Now, so you can do a class diagram for any language. All object-oriented programming languages can implement this stuff in their own particular syntax. So we'll see how we implement this type of diagram in C# specifically here. So if we have, so this is stuff that you could potentially write based on the analysis portion you've done in this class. Hey, a customer has these attributes. Although as we go to, but here's kind of an interesting visual thing here. This is your template for creating a customer. This is the attributes that it has and the behaviors that it can do. and every single time you create one out of the template, then there is you can have a new variable that has basically all of the same attributes as the original. So classes are meant to be cookie cutters from which you make lots of unique ones out of it. And this is the syntax you use for doing that. So this is what happens visually based on your diagrams you've done in the past. But with code in C#, this is what makes that happen. If you've written the code that goes along with this, then to create an instance of a class, you would do a line like this: customer, my customer object equals new customer. Customer, and then make another variable, customer object, my customer object 2 equals new customer. So you say that as many times as you want, and create as many different variables as you want out of this template. Yes?
Okay, so the customer class is like a grouping of customers, whereas the my customer.
No,
object,
no,
that's-
no, it's not. It's not a grouping. This is like a cookie cutter. It's just you can make or a cloning machine or something like that. Like it doesn't exist yet. This is just the empty box from which you make lots of them out of. If you had a machine that made cars, every time you hit a button, it made a car. This is the machine that makes cars. It is not a car. It is a car-making machine.
So like a 3D
You push the
printer.
button, and out comes one of these with all the attributes that it's supposed to have. Push it again, out comes another one.
Okay.
And to push the button, you use this syntax right here. So before we would do things like when it's similar syntax as we had before. If we were declaring an integer, like a number, you might say int my int1 equals, and then set it equal to something. Well, instead of calling it an integer, you're declaring this variable. The type of it is a customer. So if we had a class that was account, or accountant, or person, or car, or whatever else it is, that name would go right here. You declare the type of the variable that you're going to make, your made-up name for that variable, as many different ones as you want, and then say new one of those. So the new keyword has special powers. So here's a detailed breakdown of what every single part of that statement is in C# that brings one of these diagrams to life in code. So in terms of what you see, this is just a partially written class right here. Part of it's missing. But these parts right here where it says private, these are variables that you've been putting in the attributes portion of your diagram. So they're just declaring. And then once we get to most of these method names, these are, if you create another line, these are the behaviors that this particular class can do. So if it were a checking account, you might have like make deposit, make withdrawal, check that you're not overdrawn, things like that. Programming is not, on the one hand it is complicated, on the other hand it's not that complicated. It's really complicated to look at this for the first time and know what on earth is going on with all this stuff, but I guess it's sort of like learning English or something. You know, it's complicated, it's not complicated. Like this looks like a function. It says public customer, but I know from experience that because this has the exact same name as the name of the class, that this is actually a very special type of method that's different from all the other ones. This one is a constructor. It's empty right now, but this is the method that gets run when you call the new statement. So these are regular methods. This is a special method called the constructor. If you had some code written for creating a customer, if you had customer class code written, you could create an instance of a customer using this command, customer my customer. You created a variable. Now you can work through the methods of that class to act upon that particular variable. So when you first, in this case, when you first create it, it's empty. It doesn't have, there's no name or address or anything set to that customer when you first create it. So you use these methods then to assign that data into this object. So this is dot notation. It's saying, so for every, this is, in each case, it's the exact same object, which I consider like a glorified variable. Glorified meaning it has lots of different parts to it. But you can set the customer's name, address, zip code, and perhaps other things depending on how you wrote it. And here's how you can get that data back out again. myCustomer.getCustomerName. In this case, that function or that method returns a variable that you can use out here. So you can put stuff into this object this way, and then you can pull it back out with the right methods and set it to other things that you might use in your code. This is kind of the whirlwind tour of programming, I suppose. So if you read these, this is more details about that. Importantly, sometimes before you get to that last function where you're getting or setting data, there's an object name that you're operating on. It can be preceded by an unlimited number of namespaces or libraries. So, but know that the last thing is either a method or, in some cases, direct access to the variable in that object. But so if you saw something that had some word dot some other word dot some other word dot some other word dot some other word, just know that all the preceding stuff is just libraries that it's embedded in. So Microsoft dot drawing dot ovals dot circles dot draw perfect circle, or so sometimes you might embed your libraries that way. Now this is where it feels a little complicated at first, but once you learn the rules, it's not that bad. I mentioned that there's a special kind of method, which is a constructor. You can actually have multiple methods that have the same name. Like in this case, where here's one method that creates customer. This one also says public customer, but it takes a bunch of input values when you create it, and then does something with those variables that come in. So what this means is when you call the new customer command, you could either access this one or you could access this one. And there's an example of that in use right here. So the one that the customer constructor that takes arguments is written this way, and the computer figures out which one you wanted, whether you wanted to use the empty one or the one that took variables, values passed to it, just based on how you create it. But it works the same way. All right, next one. All right. Now, UML is what you've been working with. So this is what I was just mentioning up here. So this type of diagram can be used to create object-oriented code in any object-oriented language. So what you've learned is in some ways a kind of a powerful thing. So whether you're working with a Python developer or a PHP developer or a Java developer or a C# developer, if you can map out the different aspects of your programming, your program or your context, the thing, your system, using notation like this or diagramming like this, they should be able to, regardless of the language, implement it. Some of the the early notation that you got, kind of, or early in the book, we didn't complicate these diagrams as much as we could, but you can take the very simplified versions of these diagrams that we created and then add things to them that make it just a little bit, that you can add on a little bit of material to these that make them appropriate for programming. So what you kind of did is like the first of maybe 2 steps. The second step would be to add in some additional stuff which provides all that they would need to write code. So for example, these hyphens mean that it's private, and these pluses mean that it's public, meaning that other classes within the system cannot access one another through these things. There's just some best practices that say, generally speaking, you don't want to let anything ever talk directly to this. So, to these private variables. For things like, if this was a bank account application, usually you want to have it go through some safety net. Like before you withdraw $1 million from the account, there's usually like another function that says, so rather than just change the number to, minus, whatever your balance is to minus 1 million. The reason why we go through other methods to access that is so that we can say, okay, first before, try and withdraw $1 million, first check if there is $1 million in the account. If there is, withdraw it, set it to less 1 million, but otherwise send back an error. So it's a safety net to go through, to get to your variables through functions or methods, alternatively. Now here's another little twist that happens sometimes. Sometimes you get underlines on here. Do you know what the underlines mean? Okay.
Key, primary key?
Primary, that's what I was thinking.
Nope. So from your class, okay, from a given class definition or a given class, like this one broke it up into two parts. It stripped out the parts with the, it took this one customer class and it put all the underlined stuff into this box and it put all the not underlined stuff into this box. If everything's not underlined like this is where you use the new statement to create one of these. So you just saw some example of this. Customer X equals new customer. This stuff all applies. The underlines are when you don't, and this is kind of, I think, an abuse of your brains as you learn programming. But the underlines, we call these static methods and attributes, meaning you don't have to use the new statement to access this stuff. What? I don't. And unfortunately, they're using classes for kind of two different things. You've seen, for example, us using the console program, right? If you want to write something to the console, to the little black box, you just do like console dot write line. Well, newsflash, you're accessing this thing, but you didn't have to use a new statement to get it into existence. Why is that? Because the way that this is written is that there is a class called console, and there is a method called writeLine, and it has an underline underneath it. So what that means is you can call the word console and the word writeLine and without doing anything special. Whereas this block right here, this is just customer. You have to get access to any of the stuff in here because there's nothing underlined. You have to use the notation customer, use a variable equals new customer, and then you can operate on it. So in particular for utilities, for things like, messing with numbers or mangling text, adjusting text in some way, reverse all the characters, that sort of thing, turn a string of text from uppercase to lowercase, etc. A lot of those utility type things work great if you create static classes with static accessible variables. But those ones would be annoying to work with if you had to declare the variable with the object with the new statement first and then use it. I don't know if that helps or not. But what you should be able to do is if I asked you a question, if I said, how many, another way of saying a class or a static variable or a static, because that's the key word you use in the code. Another way of saying a static variable or a static method is to call a class level variable or a class level method. If I were to ask you a question here, how many class level attributes / variables are in this diagram? How many are there? No. Guess again. How many class level attributes or class, let me just leave it at that. How many class level variables are in this diagram?
One.
One. Why is that?
Because,
Yeah, so let me ask a preceding question. How many variables are in this class diagram?
4.
4. How many of these variables are class level variables? 1. Okay. If I were to say how many of these, we would call these instance variables, are part of this class? 3. Yeah, they're either class variables or instance variables. Okay, down here we've got 1, 2, 3, 4, 5, 6, 7, 8 methods. How many of these methods are class level methods? 2. Meaning if you wrote out customer dot get version number, you could get that without using the new statement. But if you wanted to do customer dot get customer name, you'd have to do customer x equals new customer, x dot set customer name, set it, and then x dot get customer name.
Can you change one of the ones that aren't underlined and force it to be underlined? Or I'm wrong?
Once okay. So if I'm writing code with customer, and I wonder if there's any examples. No. Basically, I mean, this can go one of two directions. You can either use it as a class level thing with its 3 things that are part of it right now, or you could use it as like an instance of this class. And you can't see into one or the other. Like they act like 2 completely separate human beings or whatever. Like they do not cross. Like if you have, if you create an instance of a customer and call it Dave, customer Dave equals new customer. You cannot do like Dave dot get version number. Like it doesn't exist. It's not readable. It's only from the top level, the completely different thing, customer, class level thing that you can read these 3 things or access them. Once you're using it as one thing or the other in the code, you can't read the stuff from the other use of it. So it's fair to ask questions like, what's an instance variable, which is an example of a method name. All right, a lot of stuff, huh? Object-oriented design. All right, so here's just another way to look at stuff. Again, we're moving over from the analysis side of things to what if you were a programmer. So if you were an analyst, you could create a class diagram that looks something like this. This is talking about a movie application, and it's got some names of different parts of the application, different things that are part of the system, and then it's got some methods that are part of that. If we go over to object-oriented design, we have to add more detail to those than, so for example, right here, we just have a name for like movie title. But if I come over here to this design, where it says movie title, now you can't read it, but it says :string. Why is that? Because if you're actually going to program this thing, you need to know whether movie title is a number, is it a true/false value, is it characters, and so you have to just stipulate that, spell it out very clearly. Once you've spelled all that stuff out real clearly, you can easily write code from it. In fact, if you write this stuff out clearly enough in your class diagrams, there are code generators. You just click Make Code, and it will write the code for you in C# or Java. So you're almost there in terms of if you can diagram this stuff and indicate what it is in terms of, oh yeah, that variable is a as a string, and that one's a number. There are code generators then that will then write all the classes for you. So I don't know if I'd feel safe myself using it, but I know the stuff exists.
That was like 3 semesters of work right there. Gone out the window.
No, you still need to know your stuff. It's just if it's useful to you, you can do it. All right, so this one's kind of talking about stepping through that whole process. You start off with some use case diagram. You write a real detailed use case description based on that, and you can't. Now this one, don't stretch your brain on this one too much, but just know that this is how it works. Or I said don't stretch your brain. I'm not going to make you memorize any of this stuff. So just capture it if you can. If you can't, don't worry about it. If you had a use case description like this that you fleshed out for a particular thing in your system, you write down how all the objects interact with one another, all the behaviors that they need to have. You add on to your class diagrams and make them complete based on what's in these. And actually, when you go to past analysis to design, you're actually concerned with, well, what is the type of data that I'm passing back and forth here? So, whereas before maybe we just had a message or a thing you were supposed to do, now we're thinking, hey, what if you're going to enter a movie name? Okay, let's pass in movie name into this. So it's not showing that completely yet, but that would get added in. I don't think this part of the conversation is that useful. I apologize. Anyway, that's what those ones were talking about. So ignore that one. I think that was too complicated. Maybe we'll review this one next time. Creating and using objects. So once you've written all of your really great class diagrams, you can then start programming. So this stuff looks familiar now. You've got stuff in here that's, the name of the class, which are the class level variables, which are the class level methods, which one are the instance variables and methods, and you could write code with that. So this one so based on this diagram, you should be able to go back and forth. You could either, if this were filled out, you could create one of these, or for one of these, you can create that. I like how there's kind of placeholders here that says, well, hey, if you have a given class, we're going to have a place where we're going to put our class level variables, a place where we're going to put our instance variables. We're going to need to add in our constructor, and then our class methods, as well as our instance methods. So those are all the types of things that can be written based on this. And you've seen all of that stuff before in the previous slides related to C# code. So there's the easy way that you create a constructor. That's an empty constructor. Doesn't do anything really, other than set aside memory space when you run it. Here is how you would create a class level variable. So there's a bunch of pieces of information that were used here. I can see that's minus, so it's private. It's underlined, so it's a class level variable, and the keyword for that is static. So I use the word private static, and then it didn't really indicate here what the type was, and it could. We could have like a colon string, and that would now allow us to more easily have put that part there. But anyway, a lot of different things on there from that one little highlighted line. Here's examples of how you'd write code that would align with this. So like I said before, usually you want to access your instance variables through some type of safety net. And so this one says, well, actually, these are the static variables, which is different, but the class level methods. Oddly enough, well, it's the same principle though. On the previous slide, we showed how to declare a class level variable. These are methods to access the class level variable. So you can read it and you can set it. If you take away the keywords static on all these, then they'll act like just the rest of it. So this is what I mean by the rest of it. These are just like the stuff above it, or the stuff that came before this, but it lacks the word static, meaning they're not class level variables. So here we're declaring them very simply as strings. To access those, we will need to access them through methods that don't include the word static in there. So there's the safety net, the way of accessing those variables through a method within the class. Generally, simple syntax there. Here's some of this additional information that can be put into your class diagrams. So put in there the type of variable it is, put in there the type of variable that it returns. In this case, it's a get method. You can put in the type of data that's passed in. Notice that for set version number, we're going to be sending in a variable called new version number, and it's of type string. And then at the end of this, there's this colon here that says void. What does the word void mean? You've seen that a lot.
Empty?
Yeah, it means nothing. So it means send back nothing. So this variable, right, or this method right here says get customer name, return a string. This one receives some data, but then it returns nothing. So that's just a formal way of saying, you know, sometimes you're returning something and sometimes you're not. This is your lab/homework assignment tonight. It contains this idea that if you had a class which had a mix called customer with a mixture of class level variables and instance variables, how could you play with this code to see how it works? Well, you could write two different classes. One would be a class that contains all of the data about a customer generically, the cookie cutter, the template, the machine, right? The code that represents the machine. But then you can write a test class which basically tries all the buttons in there. Just tries to do everything that you can do to a customer object. So here's code that's going to do that. So through a typical console application that starts with this, you can then start messing with other code that's available. So talking with the class level method here, creating an instance of the class there, accessing the instance of the class, writing out information about that class level variable to the console line, writing information about the instance variable to the console line there. Hopefully as you go through that in the homework assignment, it makes total sense. You're using the customer object in all the ways that it can be. You're writing to every method. So when we talk about a test class, usually what we want to do is we want to try out every single part of the code that we've written to make sure it works good. And so that means calling every method and using every variable in there. And so that's what this test class does. It says, okay, with the customer class that you've written, try out all of its parts. And if something throws an error when it's running, then you know you did something wrong. So the things that we talked about today will get a little bit clearer by doing that homework assignment. So it's just a real quick lab. So within D2L, there's a lab where you write this code and you give me a screenshot, and that's it. So, any questions? So between now and next class, I will think about what I think we have covered in depth well enough to test you on it. and then I will let you know in the next class what it is that you'll be tested on, and we'll do a review of that in class.
Last test.
I plan to focus primarily on the stuff that came since the last test, but but I don't know. I'll think it through as I start creating the test. If it seems like we could pull some stuff from the beginning and it just naturally makes sense, then I will. In the past, what I've done is had some like matching vocabulary words from early on in the class, perhaps, but then everything else on there is from the second half of the class, or the last portion of the class, rather. So,
Is the exam on the 5th?
I believe that we have a scheduled day for this class that's perhaps around the 5th. I don't know which day it is exactly.
In 2 weeks? So we
Yeah,
have a class-
yeah, it's probably in 2 weeks.
So next week we have the reviews and the
Yeah.
exam. Uh-huh.
Awesome.
How many questions?
How many questions? I want to make it worth your while. If you're going to come here, I don't want to make you drive all the way to campus and only give you like 10 questions.
No, I cycle, no problem.
I appreciate you being willing to take one for the team, but I just don't want anybody to feel robbed for their tuition. So,
You can vote on it.
We don't need it.